Hello everybody! Today I can use the angle properties of parallelograms to solve various types of questions. So the last lesson we focused on the segments properties. Today we're going to focus on the angle properties, and there's really two different types of questions that we're going to see. So let's get right into them. Now, this picture is very much like something we did earlier this year. Since a parallelogram has opposite sides parallel, what we have here is parallel lines cut by a transversal. We have this picture. Now, if you remember, for this picture, we always want to ask ourselves, same or different. If the angles are the same, by same, I mean both acute and both obtuse, they're going to be equal. If they're different, and by different, I mean one acute, one obtuse, then they add to 180. So, acute, obtuse, they're different, so they're going to add to equal 180. So, 3x plus 20 plus 10x plus 30 equals 180. I combine like terms. 13x plus 50 equals 180. I don't know what happened there. Minus 50 minus 50. 13x equals 130. X is 10. It wants FHQ. H. Let's go a different color for this one. Well, I don't have an expression for H, but I do know in a parallelogram that the opposite angles are congruent. So if y is 10x plus 30, then h is 10x plus 30. So it's going to be 10x plus 30. X is 10, so it's 10 times 10 plus 30. And I get 130 as my answer. So with algebra, let's kind of put the notes somewhere. With algebra, if you have algebraic expressions, same or different. If they're the same, by the same I mean both acute or both obtuse, set them equal. And if they are different, one acute and one obtuse, add them to equal 180. It's really bothering me that I put that extra E on there somewhere. Where'd it go? Both. So again, this is the same as the lesson we did earlier this year in the very first unit. Whenever you had parallel lines cut by a transversal, it's literally the same exact thing. Now, something else that we used, though, is we did use the parallelogram properties. At the end, we used that opposite angles are congruent in a parallelogram. The other properties that you need to know deal with angles in a rhombus or a square. The diagonals bisect the angles. What you also have, I guess, is more for all the parallelograms. And we also know that in a rhombus, the diagonals are perpendicular to each other, forming right angles. And then what we also have in the parallelogram is you have alternate interior angles formed, since the opposite sides are parallel. So those are things that may come up. Let's jump right back to the example. So again, for this one, Because there was algebraic expressions, I have to ask myself same or different. They were different, so they added to equal 180. All right, again, I've got my parallel lines cut by a transversal. Now, again, the question you want to ask yourself, same or different? Acute, acute, they're the same. So since they're the same, I set them equal to each other. They're also opposite angles of a parallelogram, and we talked about here that opposite angles of a parallelogram are congruent. Either way, you're setting them equal to each other. We do the algebra. X6. It's asking for, I have no idea what it's asking for. I don't know where the problem is. Is it hidden? Oh, BCD. Angle BCD is that one right there. So it's 8 times 6 plus 8. Use a calculator if you need to. 56. So if the angles are the same, in this example, they're both acute, they're the same, set them equal. If they're different, one's acute, one's obtuse, then they add to equal 180. So that's going to be the first section of this. Number 3 is going to be like that. Now, number 4 is going to do something different. So in rhombus ABCD, let's draw a picture for that. ABCD, angle ACD. So we got the diagonal there is 30. Find BDC and explain your answer. BDC. Well, in rhombus ABCD, ACD is 30. All right, so let's take a look. So I'm going to draw on the other diagonal. And I know that in a rhombus, the diagonals are perpendicular to each other. So now, within this picture, I see a right angle, which we kind of did in yesterday's lesson. And in that triangle, I have two angles, and I want to find the third. So 90 plus 30 plus x equals 180. The angles of a triangle add to equal 180. Minus 120, minus 120, x is 60. Now, that's it. It's asking for angle BDC. So basically what we used here, since to explain your answer, well, the diagonals of a rhombus are perpendicular to each other. So that created the right angle. And then once you had the right angle, and we had one angle already, I used the angles of a triangle add to equal 180. All right, number 5, OME is 76. Find YON. So if you just want to try on your own first, you can. It's a little bit different than the ones we did, but it's the same concept where you're using the properties of the rhombus to kind of get to your answer. And again, you can refer back to those properties there. Diagonals are perpendicular to each other. We used that in the last example. Diagonals bisect the angles. And we also know that opposite angles are congruent. And we know that if we have a transversal, that alternate interior angles are congruent. So if you want to try it on your own, try it on your own, but I will go over it now. OME is 76. This whole thing is 76. It wants angle YON. Well, if this is 76, then this, since one's acute and one's obtuse, they must add to 180. So 76 plus x equals 180, minus 76 minus 76, x equals 104. Now it wants this piece. Well, in a rhombus, the diagonals bisect the angles. So that angle is being cut in half to be 52 and 52. And it's asking for angle YON, so angle YON is 52. Explain your answers. Well, I used that the diagonals of a rhombus bisect the angles. That's why I split the 104 into 52 and 52. And then I use that the consecutive angles of a rhombus are supplementary. I guess it's like 3 different types of questions on this in this lesson. There's the algebra. Then there's these where you're using properties to kind of fill in stuff. And then that brings us to this. So if you remember in the first unit, we did a lesson called complex triangle problems. This is directly building on top of complex triangle problems. Complex triangle problems, the key was to always look for linear pairs and to look for angles of a triangle. I don't even know where I wrote that. Here, perfect. Look for triangles. Look for triangles. Look for, I'm going to say look for linear pairs. Look for angles of a triangle. So, remember, a linear pair is a straight line that's cut. They add to 180. The angles of a triangle we dealt with earlier, that also adds to 180. What else did we do earlier this year? Vertical angles. When there's an X, vertical angles are congruent. That can come up. Now, new for this lesson, the opposite angles of a parallelogram are congruent. We talked about that, a couple days ago. That's one of the properties. And the consecutive angles of a parallelogram are supplementary. So again, we kind of talked about that. In a parallelogram, the opposite angles are the same, and the consecutive angles add to 180. The 3 angles of a triangle add to 180. It's nothing new. Also, if it's a quadrilateral, the 4 angles of a quadrilateral add to 360. So that may come up in this lesson. That might have come up a little bit when we did it initially, but we didn't really see much with that. Understand as well that there may be more than one correct way to get to the answer in these questions we're about to do. Obviously, there's 9 things here. There are multiple routes to getting to the correct answer for these. 6, isosceles triangles have congruent angles opposite congruent sides. That was very important. If it tells you that 2 sides are congruent, then we mark those angles are congruent. Equilateral is 60, 60, 60. That's easy. Just if it says equilateral, all the angles are 60, 60, 60. An angle bisector cuts an angle into 2 congruent halves. We kind of used that earlier. If an angle is being bisected, then it's cut into two congruent halves. And then parallel lines cut by a transversal, all the acute angles are the same, all the obtuse angles are the same, so that may come up as well. So there's a lot of different tools that you have here available to you, and there will be more than one correct way to do it. But for these problems, just like when we did complex triangle problems initially, look for linear pairs, look for angles of a triangle to get started. So I am looking for linear pairs. I am looking for angles of a triangle. I do see a linear pair here. As of right now, I don't have enough information to deal with that. So it's telling me that it's a parallelogram. The key for parallelograms, the key property, I think, for angles at least, is that opposite angles are congruent. So if this angle is 70, then this angle is 70. Because opposite angles of a parallelogram are congruent. Now I see a triangle. Look for angles of a triangle. Whenever I have two angles of a triangle, I can find the third by adding them to equal 180. Now, back to that linear pair. Whenever I have a linear pair, once I have one angle, I can subtract from 180 to find the other one. It's asking for angle KSO. That's what I just found, 135. Something else you could have done, if you remember exterior angle theorem, the exterior angle is equal to the sum of the two non-adjacent interior angles. You could have done that. And again, there are multiple, options to get to the correct answer. I could have also done, well, if this is 70, then this whole angle is 180 minus 70, which is 110, which means that this angle here would be 110 minus 65, which would be 45. And then you can use alternate interior angles to make this 45, and then use the linear pair there. There are so many different ways to do it. The first way that I do it, I think, is always the best. I'm going to look for the opposite angles of the parallelogram. I'm going to look for linear pairs. I'm going to look for angles of a triangle. I got D is 112. It's telling me that it's a parallelogram. So I want you to start with that. I want you to try on your own right now. Take about 10 seconds. If ABCD is a parallelogram and angle D is 112, I want you to fill something else in. Take about 10 seconds to do that. Okay, if ABCD is a parallelogram, opposite angles are congruent, so that angle is 112. CE is congruent to BE. Now this goes back again. We talked about it a few minutes ago. We did it a lot a few months ago. When you see that two sides are congruent, mark the sides, mark the angles opposite them. So CE is congruent to BE. We mark the angles opposite them. Look for linear pairs. Angles of a triangle. I see a linear pair right there. 180 minus 112 is 68. So if this angle is 68, I mark that these two angles are the same, so that angle is 68 as well. Look for angles of a triangle. I see this triangle. I have two angles, so I can find the third. That's 136 plus x equals 180 minus 136 minus 136. X is 44. This is a very, I would say out of the whole lesson, this is probably the most common thing I would expect you to see in the Regents. This question right here. And you're going to see a couple more like this. You're going to use the opposite angles of a parallelogram are congruent. You're going to use the linear pairs. You're going to use isosceles triangle theorem. This is the most straightforward and common thing that you're going to see. So again, look for the opposite angles being congruent. Look for your linear pairs. Look for your angles of a triangle. And if it says that two sides are congruent, then you mark those sides as well as the angles. I want you to try number 8 on your own. The only hints I want to give you, AF is congruent to DF. So when you see that two sides are congruent, mark the sides, mark the angles opposite them. It says it's a parallelogram. Again, the main property for parallelogram is opposite angles are congruent. Beyond that, I want you to try it on your own. So please pause, complete number 8 on your own, unpause. Okay, now that you tried number 8 on your own, the measure of angle R is 124. Let me make this bigger. So since it's a parallelogram, opposite angles of a parallelogram are congruent. So that's 124. It's telling me that AF is congruent to DF. So mark the sides, mark the angles opposite them. I see a linear pair. That's 56. So this is 56, and this must also be 56 since they're the same. And now I see this triangle. I have two angles of the triangle. So I add the three angles to equal 180. X is 68. Look for linear pairs. Look for angles of a triangle. If it says parallelogram, your go-to is opposite angles are congruent. If you see that two sides are congruent, mark the sides, mark the angles opposite them. That's nothing new. That's going back to what we did earlier this year. And that's it. You go from there. I think I'm done with you. I think I'm going to let you do the rest on your own. Maybe I can do one more with you. Let's do one more. Let's do number 12. I want you to try it on your own first. So please try number 12 on your own. So pause, try number 12 on your own, and then unpause. Okay, angle MON. Let me make this bigger. Make it as big as I can. Angle MON is 75. Angle OES is 120. ONS is 95. And it wants ESM. So there are different ways to do this. I actually see a very quick and easy way to do it. So I'm going to do it that way. I see a quadrilateral. I have three angles. So to find the fourth, I can add them to equal not 180, but 360. I combine like terms. I do the algebra. I get 70. Now that I have that, I see a linear pair. So 180 minus 70 is 110. And I'm done. So when it says to explain my answer, well, I used that the angles of a quadrilateral add to 360, and then I used that linear pairs are supplementary. There are so many different ways to do it. I'm going to do it another way now. I'm not going to do it every possible way imaginable, but let's do it another way. Using some more properties that we've talked about. So let's just stick with what they gave me for now. Let's go and do this orange. I like orange. If you watch my videos, you know that. All right, so I don't have that 70 yet. So let's just get rid of that. So if this is 75, then that's 75 because opposite angles of a parallelogram are congruent. If this is 95, then this is 95. Now, they're not opposite angles of a parallelogram, but they're alternate interior angles. Now that I have that, let's see. So if this is 120, I see a linear pair there. That would make this 60. Since this is 75, then this angle is 180 minus 75, which is 105, which makes this angle 10. And now I have a triangle. I have two angles of the triangle. So 10 plus 60 plus x equals 180. 70 plus x equals 180. And it would be 110. So again, there's a lot of different ways to end up at the correct answer. There's other ways I could have done it as well, but I just wanted to show you a few of them, but it's just good to know what you have available to you. Opposite angles are congruent, alternate interior angles are congruent, angles of a quadrilateral add 360, angles of a triangle adds 180. There's just so much at your disposal. So your classwork/homework is to finish this. Very, very important, especially the second half. Very, very important Regents question. Also, it's a common SAT question, but really, really, really common Regents question. It comes up not just once, it usually comes up twice, these types of questions on the Regents. So really, really important. Also important in the SAT, so make sure you're prepared for it. The first half, not so much, but definitely the second half. So again, I can use the angle properties of parallelograms to solve various types of questions. For the algebra problems, ask yourselves, are they the same or different? Same, set them equal. Different, add them to 180. And then you have these angle properties, which you're going to combine with your complex triangle problems that we did earlier. Have a great day.